Hello and welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based in Europe, and I'm going to be your host for this session. And today's session is a Masterclass series webinar focused on Amazon Redshift, which is Amazon's petabyte scale data warehousing service. And this particular webinar, as we've said, is a masterclass. So we're going to be taking a technical deep dive here beyond the basics of Amazon Redshift, hopefully helping to educate you on how you can get the best out of this particular AWS technology, show you how things work and how you can get things done. We'll spend about 45 to 50 minutes going through the content that we have for you today, and hopefully leave a few minutes at the end of the session for any questions that you may have. And if you do have questions, you can submit these at any point during today's webinar using the Q&A panel that you should be able to see within the webinar interface. We will respond to as many questions as we can during the Q&A section at the end of today's session. But if we don't have time to respond to your question, or it's a question that's complex, don't worry about that. We have a solutions architecture team here at AWS that are on standby to answer questions from this webinar. We'll get back to you within 4 to 5 days with written responses. And in fact, if we answer your question during the session today, we'll still write to you with a response and include a few references and some follow-ups that you can take a look at to learn more about the area that you're asking about. So that's questions. Also at the end of the session today, you will see a rating panel appear in the webinar interface. We'd love to get your feedback on the session today. We're really keen to try and optimize these webinars and make them as effective as possible. So if you could give us a score from 1 to 5 for today's session, with 5 being the best. And also, if you have any quality feedback that you'd like to leave about how you think we can improve or optimize the content from today's session, please leave us a question with the feedback in it. It'd be really, really helpful for us if you could do that. The other thing that you're going to see at the end of the session today is some social media links. So be ready with those. We're going to show you some links that you can use to stay up to date with our evangelism team and also with AWS service launches, with AWS news and events here in English language in Europe. So if you're ready for those at the end of the session, that might also be helpful for you. And lastly, the materials from today's session, they're available now actually in the files panel that you can see on your screen. So you can click that and download a PDF of the presentation materials that we're using. We'll also send around after the webinar today a link to a recording of this webinar on YouTube, so you can rewatch it or share it if you want to do so. And also a link to the slides on SlideShare once again, so you can review the materials a little bit more easily without having to download them, and also share the materials with any colleagues that you think might be interested in them. So that's logistics. Just to quickly mention also, we have one other webinar series that you might be interested in called the Journey Through the Cloud series of webinars. It's a more solutions orientated set of webinars where we're focusing on particular challenges that you might solve with AWS services. You might be running development and test workloads, or implementing disaster recovery in the cloud. We've done quite a few of these this year, quite popular, so you might want to take a look at those if you haven't already done so, and have a look at a solutions orientated approach to how you might use AWS within your organization. Okay, so let's move on and talk about Amazon Redshift. So it's a fast, fully managed petabyte scale data warehouse. It makes it simple and cost effective to analyze all of your data using existing tools. And it's possible to start small with Amazon Redshift, but scale to a petabyte or more of data. So it's very scalable, and it's very low cost, costing less than $1,000 per terabyte per year. So you can really achieve very good economics for running data warehousing workloads within AWS. We believe that this is substantially more cost effective than traditional data warehouses that you might run on your premises. So it's a good candidate for moving to the cloud after some TCO analysis to validate that. What are the fundamental characteristics of Redshift? Well, it's optimized for data warehousing. So it's a fast data warehouse. It uses MPP, massively parallel processing architectural concepts to parallelize and distribute SQL operations across all of the available resources within your cluster. And we'll talk quite extensively today in the session about precisely how it does that and how you can optimize your data to ensure that you take advantage of that characteristic. It uses local storage attached to each one of the nodes in the cluster, and it uses a 10 gigabit mesh network to maximize throughput between the nodes. And this means that it's very scalable. So scalable in the first instance because it makes good use out of the resources that are available to it, but also scalable because it's very easy to resize, migrate data to a resized cluster, and then cut over to using that new cluster for your data warehousing and analysis workload. So it's a service which is very easy to scale. In common with most the vast majority, in fact, of AWS services, there are no upfront costs. So you can pay as you go with on-demand pricing for your data warehouse using Redshift. You can choose to use reserved instances to further lower your pricing, and that is a prepayment model that you can use for optimization of your costs. But you're by no means forced to do that. If you want to use Redshift on demand, you're perfectly free to do that. Use it as you need it. Stop using it when you don't need it, and only pay for it when you are. It's simple, so we'll walk you through the very simple process that you use in order to create a cluster during today's session. But it uses the familiar AWS Management Console that you've probably seen many times before. And we have a very simple wizard-driven approach to creating data warehousing clusters that you can then make use of. Once you've created your cluster, it's fully managed, so we handle all the work required to manage, monitor and scale your data warehouse, monitoring the health of the cluster, taking backups, applying patches and upgrades, etc. So it just makes it very, very simple for you to make use of the data warehousing features without having to deal with a lot of the undifferentiated heavy lifting that normally comes with operating this kind of infrastructure. That extends to, as I've said, backups and restores. Security is built into the product, so it's very easy to set up Redshift to use SSL to secure data in transit, and using hardware accelerated AES 256 encryption for your data at rest. So it's a secure environment, and it sits within the familiar Amazon VPC, virtual private cloud construct, that you might use for other AWS services that you make use of. And that means that you can very simply and easily connect Amazon Redshift to your own virtual network and connect that back to your existing IT infrastructure using either a VPN or the Amazon Direct Connect service. So it's very easy to integrate it with existing networks. We provide audit and compliance features, enabling you to audit API calls with CloudTrail, also logging SQL operations, connections attempts, queries and changes to your database, etc. So it's a very visible environment, or an environment where you have very good visibility, and you can use that for audit and compliance controls. And then lastly, compatibility. So it's an SQL data warehouse, and it uses standard ODBC and JDBC drivers. So many popular software vendors have already certified Amazon Redshift with their BI or ETL tools. And to the most part, you can use existing ETL and BI tools with Amazon Redshift without having to change a whole lot. Furthermore, you can integrate it with other AWS services. So, for example, parallel loading from Amazon S3 or DynamoDB is something that's supported. You can integrate it with other AWS services that you might be using, such as EC2, Data Pipeline, or Kinesis, to use Redshift as a data target to add analytics to, for example, streaming data that you might be processing with Kinesis. So a service that's really well integrated both with existing tools that you might use and with other AWS services that you may be using. That's a quick overview. What's the agenda for today? So the first thing we're going to do is take a look at why you might run a data warehouse on AWS. Then we'll have a look at getting started with Redshift, talk about table design, data loading, how you can work with your data, a quick section on backup and restoration, quick section on upgrading and scaling, and then we'll show you some resources that you can use to learn more. So quite a full agenda for today's session, so let's move quickly today. Why would you run your data warehouse on AWS? And the first thing to talk about is, in general, why you might choose to use an AWS managed database rather than run your own database. So this applies equally to Amazon RDS, our relational database service, to DynamoDB, etc., to EMR. So why would you do that? Why would you opt to have Amazon Web Services manage your database rather than doing it yourself? And the simple answer to that is, a lot of the opportunity to get value out of cloud computing is about stopping doing things yourself and letting other people do them for you that might have a higher scale, might have invested in automation, might have very good economics by virtue of their scale. And that's what we can offer, what AWS can offer to you as far as Redshift is concerned. So you can stop doing a lot of things that are related to the operation of your data warehouse, and you can focus your efforts on things that genuinely deliver you more differentiation, make you more competitive, such as developing queries or performance tuning existing queries on your data, rather than things like, for example, security planning or installing, upgrading, patching and migrating your data warehouse, or dealing with backup and recovery or data loading tasks. So We think that by using a managed database, you can stop doing a lot of stuff and refocus the effort that you might have spent dealing with that undifferentiated heavy lifting on things that are going to add more value to your organization. And customers were asking Amazon Web Services to deliver data warehousing in a way which is consistent with the other AWS services, so shares some of the characteristics of the other AWS services that we previously delivered. So things like being easy to provision and having the ability to scale to massive levels, avoiding upfront cost, and having an option for pay-as-you-go, an on-demand pricing model, really fast performance at a really low price, and being open and flexible with support for popular BI tools that customers are already using. And those are the kind of tenets that we've encapsulated in the Redshift service that we've created. From a technology perspective, Redshift is an MPP database, as we said, a massively parallel processing database. And this extends to everything, this parallelization and distribution. So whether it's query, load, backup, restore, or resize, all of those activities will take place in parallel, making use of all of the compute resources that exist within your Redshift cluster. Maybe more importantly, making use of all the memory and I/O resources that exist within the cluster as well. So we'll talk later in the session today about precisely how that's achieved, but it's makes very efficient use of the resources that are available to it. And you have these characteristics of being able to scale your data warehouse. So you can start very small. You might have a single node with 160 gig solid state drive or a 2 terabyte magnetic drive. You might just use that for piloting or testing your ETL and queries on a very scaled down environment. You can then use up to 2 to 32 nodes with the extra large nodes, again with 320 gigabyte SSDs or 64 terabyte magnetic capacity in total. And that will allow you obviously to scale out the amount of compute, I/O and memory that's available within your cluster. And then if you've got a really significant workload, you can use the 8 extra large nodes, which will give you 24 spindles, 120 gigs of RAM, 1.2 terabytes SSD or 16 terabytes magnetic, and you can cluster between 2 and 100 nodes there. So you can build a very large data warehousing cluster with a large amount of I/O capacity and a large amount of memory. And Redshift will enable you to parallelize the operations that we talked about on that previous slide across that very large farm of compute resources. So you get access to a very large amount of performance capacity, which you can use to run your workloads. And as we've said earlier, simplification of operations is a key component of what we've tried to do with Redshift. So building in security, building in that backup and restoration management functions, and building in failure recovery functionality. So for example, if you have a node failure for any reason, that node can be recovered transparently to you and your data redistributed into it. And we're integrating the service with Amazon S3 to provide those data protection services, those backup and recovery features that we talked about a second ago. We're using modern practice as far as the design of the data warehousing software service is concerned. So things like columnar data storage, which is optimized for scan access patterns, giving customers some opportunities and capabilities to tune performance by managing and controlling how their data is distributed and keyed across the cluster, and also providing functions in the console which will enable you to identify and tune queries that might be resulting in poor performance. So you can do some limited SQL profiling within the console that will enable you to identify poorly tuned SQL that you might have. Also using a technique called zone maps, which means that for each data block we store a column's minimum and maximum values for the block, so we can identify without having to execute a query what range of values exists within that data block. So if we don't need to read that block, we won't do so. We'll know that before the read operation commences on that block, because we know the range of values that are there, and that can simply remove the requirement for you to perform IOs for certain queries, which can of course further improve performance. So we've got this modern data warehousing software architecture which is intended to reduce I/O and improve query performance. And if we look at a couple of examples of customers that have used Redshift and some results that they've got, you'll see that this isn't just theory, it also works in practice. So we've done quite extensive piloting with data sets from Amazon.com, from Amazon retail business, looking at very large data sets. So testing with a 2 billion row data set, running 6 representative queries on a 2-node Amazon Redshift cluster. So 2 billion records, 6 representative queries, and we were running this on a 2-node cluster, comparing it to an existing 32-node traditionally architected data warehouse, which was actually much larger in terms of memory as well than the Redshift cluster. And the query response on Redshift was between 12 and 150 times faster. And you can see some examples there at the bottom right of the 6 most complex queries that we ran against this set of test data. The most extreme example of performance improvement was a query that previously took just short of 30 minutes. And we were able to execute that query on Redshift in just 12 seconds, which is 149.8 times speed up. And even the lowest performance improvement was a factor of almost 13, going from 2 minutes 9 seconds down to just 10 seconds. So you can definitely see significant performance improvement with real-world query-orientated workloads on Amazon Redshift. And it's not just within Amazon where this has been proven. So we've got many production customers that are using Amazon Redshift today. A great example of that, actually here in the United Kingdom, where I'm located at the moment, is the Financial Times. So the FT publishing, as you'll be aware, across a variety of different platforms. They're using Redshift to support a variety of different analytics workflows within their organization. One of them is content personalization and recommendations that they make on their digital titles, but also for a variety of other analytics purposes as well. And you can see here a quote from John O'Donovan, who's the CTO at the Financial Times, saying that when they first implemented Amazon Redshift, they thought the system was broken because the performance improvement was so significant. Some of their queries were running 98% faster than they had previously, so there's obviously an opportunity there for the FT to make decisions much more quickly. But that dramatic performance improvement led them to think that there might be an issue with the system when they implemented it. So for a few queries, they reran those queries on their traditional data warehousing infrastructure just to make sure that the queries were actually executing, because the performance improvement was so significant. So another great example of a customer that's had super success with Amazon Redshift. Okay, so let's move on now and take a look at getting started. How exactly do you create, instantiate an Amazon Redshift cluster using the AWS Console? And we're going to show you here that you can create a data warehouse in just a few minutes using Amazon Redshift. So if you jump onto your AWS Console, you'll see your familiar list of services there, and you'll find Amazon Redshift under the database section. You can see it highlighted here with that yellow box at the bottom left of this screenshot. So if you click on that, you'll be taken into the wizard, which will enable you to launch a cluster. Just click the launch cluster button, and you'll be asked for a few details: a cluster identifier, a master username that you want to use for your database, and passwords, and obviously confirmation of that password that you're going to use. So we've populated that to create a cluster called my cluster with a master username of master and a password which you can't see. Click the continue button, and you'll then be asked to specify what kind of nodes you want to use to create your data warehouse. We're using the DW2 large nodes here with solid state storage, so 160 gigs of SSD per node and 15 gigs of memory per node. In this particular instance, we're just going to create a single node cluster, but you could quite easily switch that to multi-node and enter whatever number of cluster nodes you wanted to in the allowable range. But in this case, we're just creating that single node cluster. We're going to click continue, and then we'll be asked to enter some further details which will allow us to set security parameters, networking options, place our Redshift cluster into a VPC security group, and also optionally, as you can see here, create a CloudWatch alarm that might be used to notify us if disk usage on our cluster reaches a certain threshold. So we're, as you can see, integrated here with a variety of other AWS services. We're just going to leave the defaults in this case. And then if we click continue, we're presented with a summary of the cluster that we're about to launch. So it'll just allow us to review and confirm that we're happy with the configuration settings that we've chosen. Scroll down again and click launch cluster, and that's it. Our cluster is now in the process of being created. In just a few minutes, the cluster status will change to available, the DB health will change to healthy, and in maintenance we'll switch to no. And if we click on our cluster, then we can see that our cluster has successfully been created. And looking at the cluster database properties, which you can see here highlighted in the yellow box, you're given an endpoint that you can connect to using your BI or ETL tools, using the password that you set previously with the username that you can see there. And you're also provided with JDBC and ODBC URLs that you may paste in if you're using those particular drivers to provide access to the data warehouse cluster that you've just created. So it's a really, really simple process, as you can see, with this wizard-driven approach to creating your Redshift cluster. If you want to know more about getting started, there's a really excellent getting started guide available for Redshift. I really encourage you to read that. Even if you're familiar with the service, it's a great refresher. It's frequently updated, and if you're new to it, it's the best resource to use to learn about how you can get started with Redshift. Also, you should be aware of the fact that there's a 2-month free trial running in many AWS regions around the world, so check that out. It might be possible for you to get an extended trial of Redshift and do some real serious proof of concept work with it during that free trial to establish performance characteristics and integrate Redshift with ETL or query tools that you might use. There's also, as you'll see in a second, some really good tutorials for table design and data loading, and that's going to be what we talk about next actually. So let's take a look at table design with Amazon Redshift, and this is a really important aspect of using Redshift efficiently and effectively. The reason for that is basically twofold. Firstly, it's important to choose the right data type for the data that you're using so that it's represented correctly within the model that Redshift uses. And secondly, the distributed nature of Redshift, the MPP characteristic, means that it's really important that you distribute and sort your data in a way which provides for optimal use of the resources within the cluster. So that's what we're going to look at in this section on table design. Just a quick tour of data types. So these are the data types that you can use to classify data that you're loading into your Redshift environment. And it's important to choose the right data type, appropriate data type for each column or field within your database. So please review this carefully and make sure that you're setting appropriate data types for the data that you're going to be loading into your cluster. Typically, of course, you'll be working with third normal form data models when you're working with relational databases. But there's a reason that this might not be the optimal way to work with your data if you're loading it into an MPP data warehouse for analysis. And that's really twofold. The first is to do with compression. The second is to do with distribution and sorting of your data across slices or across nodes in your MPP cluster. And this is about avoiding unnecessary I/O between nodes in the cluster. And maybe slightly counterintuitively, denormalization of your data can improve query performance by simplifying data layout and removing crosstalk or internode communication within your cluster. And we're going to talk about that a little bit now. So Redshift's a distributed system, as we've said. You've got a cluster that contains a leader node and a number of compute nodes. And each compute node is going to contain a number of slices. So that's one slice per core typically. And each of those slices contains data. And there's a couple of ways in which those slices might be chosen. The first is round robin, but the second is based on distribution keys, which is a hash of a defined column within your database. And queries want to run, and for optimal performance, should run on all slices in parallel with data evenly spread across slices. And if you don't distribute your data appropriately across slices, you can end up with a suboptimal distribution essentially. So, and as you can see here, if you've got order 1 and you're joining that with items, so item 1.1 and item 1.2, if order 1 and item 1.1 and item 1.2 are in different nodes, then you're going to have crosstalk across nodes, across the across the local area network. And ideally, you want to try and avoid that by organizing your data like this so that your joins happen locally on your nodes rather than them taking place across nodes. So with an optimal distribution, you'll use a distribution key to group data about a specific key on a predefined slice. And then joins will take place within that individual slice rather than having to transit the network and introducing latency. So this is the distribution key hashing that we talked about a second ago, and it makes aggregation and operations much more efficient. So aim to try and structure your data in this way when you're doing your table design. And the distribution keys that you use, ideally you want to be looking at frequently joined data, so maybe the most commonly run queries or the queries that consume the most CPU, and distribution keys want to have a large number of discrete values. They're going to be hashed, and with a large number of discrete values there'll be good distribution in the hash key, so you won't have read hotspots in your data set. So that's pretty much everything to say about table design, I think. If you visit the URL that you can see at the bottom of the screen here, you'll find much more detailed documentation about table design with Amazon Redshift. I really encourage you to read that. Sorting data, again, it's useful also to think about the slice and node based architecture that we're working with here. And having your data sorted appropriately can help optimize performance of the cluster. Redshift stores column data in blocks. So for the sort key, the data blocks are marked, as we've already said, with the minimum and maximum value of the column. So this will allow Redshift to skip reading blocks that are not relevant to the current query. So if you use sort keys, that can help you take advantage of that feature and avoid reading entire blocks if you don't need to do so. So for example, if you've got a table that might contain timestamp, if you sort on that timestamp, if you're querying only recent data, blocks that contain old data will be skipped, so you won't carry the I/O for that, and your query performance will be significantly improved. Just going to touch briefly now on steps that you can take to optimize your schema. So how to optimize your schema to optimize your database for querying. The first thing to say is that you can, as we've already said really, co-locating frequently joined tables using a distribution key to help avoid data transfers between nodes is a very important aspect of schema design. So you want to join your tables essentially so that the tables will be pre-joined within the slices, and that queries, when distributed and executed in parallel, will have local access to the data that they need. And this can mean in some cases that you might denormalize and join commonly used attributes into large tables. So essentially you can see an example here where we might denormalize and pull things like the airport group or the airport within a larger table which contains both halves of the join key essentially. And there's another technique that you can use in this sort of scenario if you have small tables, which is to use table caching. This would essentially copy the small tables onto each node within your cluster and therefore remove the requirement for them to be broadcast across the cluster for joins. There's a few caveats with this. So the tables need to be small, but not too small, not less than 1 to 2 megs, and it can increase write latencies. But generally, this is a good option for when a small table cannot have the same distribution key as a large table. You might want to consider using this distyle all command to copy those small tables across nodes within your cluster. Okay, so just to quickly recap If you want to learn more about table design, as you might have guessed, it's an important part of optimizing performance of your Redshift cluster. Take a look at the table design documentation that you can see here on the top link, and you might also want to go through the table design tutorial that you can see on the bottom link, which will take you through a worked example of designing a table for optimized performance on Amazon Redshift. Okay, let's move on and talk about data loading. And we've already mentioned at the top of the session today that Redshift is integrated with a variety of other AWS services. The most common place to load data from into Redshift is Amazon S3, and that's because quite a lot of customers will bring data into Redshift from other data sources that they might already have within their organization. And if you are doing that, there's several options that you have for getting your data into S3. Direct Connect, so this is a private, high bandwidth, low latency connection between your network or data center and the AWS cloud. You can use that to establish a connection to Amazon S3, so getting your data off the internet and assuring more consistent performance for that. You can also use a VPN connection over the internet to secure your data at lower cost. Transport that to Amazon S3 over that VPN connection. You can take advantage of S3 multi-part upload, which will optimize and improve the speed at which data can be transferred from your own premises or data sources into Amazon S3. And lastly, you can use AWS Import-Export, which, as you may know, is a simple service for shipping physical media to an Amazon Web Services region, and we will then load your data from physical media into Amazon S3 from where you can access it. I've described this quite often as a high latency, high bandwidth service. There's nothing that's got more bandwidth than a truck full of 1 terabyte hard disks, and you can send large volumes of data to us for bulk loading in that way. You may also consider intermediate staging phases where you load data from your own source databases into one of those other AWS services that you can see at the top of the screen here. It might be RDS, it might be EBS volumes, it might be MapReduce for an intermediate data processing phase, or it might be Glacier if you're going to archive your data for long-term periods and only access it infrequently. There's also integration between DynamoDB and Redshift. So if you do have non-relational data, you can load that into Amazon Redshift in relational format, obviously as long as the schemas match, and you can use that as a mechanism for staging data and then loading it into Redshift. So you've got very many options for getting your data into Amazon Redshift, either direct from your own premises over one of those network options or from other AWS services. When using S3, generally what we see customers do is dump data from their DB, encrypting CSV files, uploading that data into S3 into buckets, and then sharing that with Amazon Redshift using bucket policies of the type you can see here. So this is an IAM policy that would be applied to your Amazon Redshift cluster, allowing it to bulk load data from Amazon S3. And when that data is bulk loaded from Amazon S3, if the data is split into separate data files, then parallel loading can take place. And this is a very high performance technique for getting data from Amazon S3 into a number of Redshift cluster nodes in parallel. So the copy command can load data in parallel across the compute nodes in a cluster. And if you split your data into files, those files will be divided across the number of slices in your cluster. So if you're naming each file with a common prefix, as you can see here, you might split your data into 4 files, loading that into, say, 16 slices on your Redshift cluster. And that will ensure that your data load is parallelized and takes place at high speed, so that will reduce the runtime for your cluster if you're running any cluster on demand. It's important to make sure that your data files are roughly the same size, because Redshift doesn't take file size into account when dividing the workload. So split the files into roughly the same size, and that parallel loading can be executed for you. Some issues that you might see when loading data. So these are things that you need to keep an eye on when prepping data for load and when executing the load operation. So it's important to make sure that data types match, that you've got the right number of columns and the number of fields in your import data. Don't mismatch your quote, and there's a couple of other things that you can focus on there as well. So you may hit some issues, but you can focus on these particular typical issues that customers do see. Try to avoid these when prepping your data for load. You can also execute direct SQL on your Redshift cluster. Those direct SQL commands will all go via a leader node, just so you're aware. So if you've got very, very large SQL command sequences that you're executing, it's not going to be as efficient as using parallel loading. And Redshift doesn't support single command merge, so you would load your data into a staging table typically, and then join that staging table with the target using updates or inserts. So some best practices for bulk loading. Use the copy command to load data, as we've said. Use a single copy command and Redshift will parallel load all the data in that copy command as long as that data is split into multiple files. You can compress your data files with gzip and they'll then be decompressed on the nodes before they're loaded. You can use multi-row inserts if copy is not possible, and bulk insert operations. Continuing, load your data in sort key order, as we've already said, so pre-organizing your data to make sure that you take best use of the MPP nature of the Redshift data warehouse. And if you are going to add, delete or modify large tables, you can run the vacuum command, which will essentially clear down empty rows within your tables and ensure that you're making the most efficient use of the cluster, and also have the best scan performance possible when you come to execute queries on your cluster. And then run the analyze command whenever you've made a non-trivial number of changes to the data to ensure that your table statistics are current. Again, that can help optimize. So there's a few best practices there that you may want to download the materials for and review after the session today. So once you've got your data into Amazon Redshift, how can you work with it and what kind of tools are available to you? And this is just a sort of conceptual diagram which can show a typical data flow through an environment. You'll have your transactional data retained in your OLTP linked RDBMS system. And you may want to increase or execute significantly more queries against that data source. So you're going to make use of Redshift as a data warehouse, and you're going to load data from your RDBMS into that to lift off the reporting and BI workload from your RDBMS, ensuring that your RDBMS still performs well for your online transaction processing apps, and also potentially that you've got more data available for your analysis, so longer term data retention in your warehouse. And the first thing to say is there's a wide variety of different data integration tools that are available that run and are supported with Amazon Redshift. So you can use those VPN or direct connect technologies that we talked about earlier to get your data across into Amazon Redshift over a high performance and consistently performing connection with the right level of security for your particular workload. You can also use data transfer optimization tools like a Unity Cloudbeam, which combines ETL tools together with high-speed data transfer, optimizing use of the network for you. So some tools that you can use and consider there for managing the data pipeline and integrating data from your RDBMS into your data warehouse. Once you've got your data in your warehouse, as we've already said, Redshift provides industry standard JDBC or ODBC connectivity, and you have a wide variety of BI and analysis tools that you can use with Redshift as a result of that standards-based approach. You can see just a small selection of those shown on the slide here. Many of these technologies are available in the AWS Marketplace. So the AWS Marketplace is a marketplace for ISV products that have been certified and verified to work with other AWS services and products. And there's a whole section on the AWS Marketplace devoted specifically to Amazon Redshift, where you can find all of the products that we've just talked about, plus a host of others. So if you jump onto there, you'll find a catalogue of ISV products that have been provided by ISVs who have verified that these products work with Amazon Redshift. An example product page looks a little bit like this. So we're looking at TIBCO Jaspersoft here, which is a very popular reporting and analytics tool for AWS. And you'll see that the software itself is licensed on an hourly basis. So in keeping with many AWS services, even this ISV software is available under an on-demand model. And you can see here the pricing details for Tibco Jaspersoft broken down on the right-hand side. Software by the hour, where the software charges scale in accordance with the EC2 instance type that you're going to run the software on. And the EC2 instance type pricing is also included in the total pricing that you can see on the right hand side. So you can run not only your data warehouse by the hour on Amazon Redshift, but you can also access a broad selection of different BI and other data integration tools under the same sort of commercial model, which makes the whole environment really good for testing and experimenting with new data warehousing technologies, new analysis technologies that you might want to use. So I'd really encourage you to take a look at what's available within the AWS marketplace and see whether there might be an ISV there that you want to experiment with or use in production that might be a good candidate for testing in this kind of cloud-based data warehousing environment. Backup and restoration of Amazon Redshift. Backup and restoration is handled using Amazon S3, the AWS Durable Object Storage Service. And you can have a configurable retention period on your snapshots. You could also take snapshots on demand if you wish to do that. And when you come to need to restore data from Amazon S3 to your Redshift cluster, that restoration process uses streaming, so the query functionality within your cluster will be available much more quickly than with traditional restoration processes. So at any point you can restore a cluster from snapshot and make it available for you for querying. It's one other aspect of data protection on Amazon Redshift that's worth mentioning, and that is the fact that node failures within the cluster are replaced or detected and replaced automatically without you having to take any action. So whilst we use locally attached storage within the nodes themselves in order to improve cluster performance, we also take redundant copies of your data and store that across the other nodes in your cluster, so that if a node does fail for any reason, that node can be replaced transparently without interruption to query or other operations on the cluster. And this is again a characteristic of the MPP architecture that we're using to support Amazon Redshift. Let's move on now and talk about upgrading and scaling a cluster. Very short section because it's very simple. So first thing to say is that you can resize your Redshift cluster whilst your cluster remains online, essentially provisioning a new cluster in the background. So take this 3-node cluster that you can see here on the left side of the slide. We want to change that to a 4-node cluster. Redshift makes this scaling up and down very, very easy. So behind the scenes, Redshift will place the cluster in read-only mode. It will transparently copy data across onto those new cluster nodes, automatically switching over the SQL endpoint via DNS once that copy operation has been completed, and then decommissioning the source cluster at that point. And critically, you'll only start paying for the new cluster at the point at which it's activated and that DNS endpoint has been switched across. So you don't have to make any application changes during that resize process. The only important thing to note is that during the resize process, the source cluster will be placed in read-only mode, so you can't load data into it at that point. It'll be in read-only mode, but it will still be available in read-only mode. And critically also, resize works both ways, so you can scale down your cluster just as easily, with the only requirement being that your data set will fit within the available storage on the new target. So it's a very flexible way to resize your data warehousing environment, and essentially automates a task that would previously have been probably a pretty expensive consultancy exercise for you to have executed for you by a data warehouse vendor or specialist consultant. It's completely automated and very, very easy to execute within AWS. In fact, we'll show you how easy it is. So here we are looking at an existing cluster within the Redshift part of the AWS Console. And to resize that, we're just going to click the cluster, which will then take us to the detail page. We'll then click the cluster drop down, hit that resize button. We're provided with this pop-up, and that's basically it. You just select the new node type and the number of nodes that you want within your cluster. hit resize, and that resize operation that I just showed to you a second ago will be kicked off in the background. When that's completed, the endpoint will be cut over for you transparently, and the cluster will then be available in read-write mode again. So very, very simple exercise to resize a running Redshift cluster. So a few other things at the end of the session that you might want to take a look at. There's many additional references of AWS customers that are using Amazon Redshift today. Just pulling out a couple of them. There's a great blog on the Airbnb technical blog about their performance testing with Amazon Redshift and the kind of performance improvement that they saw when they implemented a pilot environment for Amazon Redshift for part of their application. So you may wish to take a look at that. And additionally, there's a great video from last year's AWS Summit where Nokia Corporation are talking about how they've used Amazon Redshift to enhance the reporting capability for an internet access service that they provide in developing markets around the world. You can find these and also a wide variety of other AWS big data and Redshift case studies if you visit the URL that you can see at the bottom of the screen on this slide. So check that out for more information about Airbnb, Nokia, and a variety of other customers that are using Amazon Redshift today. Specifically on Financial Times, which we talked about earlier in the session, if you follow the URL that you can see here, you'll find the video interview with John O'Donovan from Financial Times, the CTO there, talking about their use of Redshift. Another excellent resource is the Redshift Getting Started guide that, again, we mentioned earlier in the session today. You can see a quick screen capture from that on the right hand side here, and you can see all the resources that are linked off that Getting Started page. That's a really excellent place to go for further information about how you might get started with Redshift. You could also take a look at the video that you can see there, which is an hour-long session from AWS Summit 2014 in San Francisco. So that was in April this year, where we're exploring and discussing uses and best practices for Amazon Redshift, similar to the content that we've covered in today's session, but without the intro stuff at the front, just all detailed stuff about how you can use and optimize your Redshift environment. So you might also want to check that video out, and that's linked out of the materials here. And of course, if you've got a specific use case that you want to discuss, or a specific migration project that you're interested in talking to us about, we've got local AWS solutions architects around the world that can help with Amazon Redshift and help you understand how you might benefit from using it and how it might fit into your environment. So you can always contact us via the Contact Us form, or you can contact us using the social media links that you're going to see in a second, and we'll find the right person in your particular geography to help you understand how you can use Amazon Redshift. Okay, so let's quickly summarize. Amazon Redshift, it's a fast petabyte scale data warehouse using this MPP architecture, easy to scale and simple to scale using the automation framework that we've provided. You've got on-demand pricing if you wish to use it, or you can pre-commit to your Redshift cluster using the reserved instance type and reduce your costs. It's very simple to use with the AWS Management Console, simple to provision, simple to resize, simple to integrate with existing tools that you might have by virtue of those ODBC, JDBC connectivity types that are supported, and also broad support for AWS Marketplace ISVs. It's secure with encryption at rest and encryption of data in transit, and it's auditable, providing visibility with CloudTrail and other AWS auditing services that are made available within Redshift itself. And it has broad compatibility with other AWS services and an ecosystem of third-party tools. So if you want to find out more, this is the URL for the Amazon Redshift product page, service page on the AWS website. There's lots and lots and lots of documentation, case studies, and the Getting Started guide are linked off here. So please take a look at that. And if you want to build your AWS skills more generally, then why don't you take a look at the training offerings that AWS have. We have self-paced labs covering a variety of different AWS services, several of which you can take for free. We have a comprehensive classroom-based training program delivered by AWS and by training partners around the world, which you can find at aws.amazon.com/training. And we also have certification tracks now for solutions architects, systems operations professionals, and developers that are working with AWS, and you can check that out at aws.amazon.com/certification. And the last thing to say in today's webinar is if you want to provide us with any feedback or stay up to date with AWS around the world, then please follow us on Twitter at these social media links. You can find me at Ian, which you can see there at the top. You can find us in the UK and Ireland at AWS_UKI, and we're publicising AWS webinars and events that are local to the UK and Ireland geography here, as well as service launches and case studies that are relevant to UK and Ireland customers. So you might want to follow us there on Twitter. And if you want to stay up to date with AWS globally, find us at AWS Cloud, and that's where we announce all new AWS services. There's lots of content there about reInvent, our global user education event, which is coming up in mid-November in Las Vegas, which you might be interested in. You can find out all about that if you follow us at AWS Cloud as well. Okay, so thanks for joining us today. We're now going to take a look at Q&A from the session. If you do have any further questions, please submit those using the Q&A panel that you can see in the webinar interface. My colleague's going to switch us over to Q&A mode now, so submit any further questions that you have in that Q&A panel. If we don't answer them in the next few minutes, we'll send you an email back on them. And of course, please don't forget to rate the session today and provide us with any qualitative feedback that you might have, once again, using the Q&A panel. Thanks for joining us. Let's take a look at some questions.